Welcome back to ACER Explained. In this series, I'm going through section 3 of the ACER practice test booklet. So bring that up in front of you if you don't have it already so that you can follow along. In this video, I'm going through questions 32 to 36, so that's unit 10. As usual, I'm going to be identifying prerequisite knowledge that you might need, reasoning skills used, as well as the bootcamp resources to help with this. So this unit is talking us through an experiment of different three different diets, and we have two tables that describe the types of diet and also some other statistics that were measured as well. So let's look at question 32. So question 32 is asking us which statement out of the four presented is least supported by the observations that we can see in the table. So we're going to go through and do a process of elimination here. So starting with A, it says an increase in fat mass is related to an increase in total energy intake. So now we have to kind of go through and look for fat mass, and that you can find in table 2. So fat mass goes from 3.66 in diet 1. Fat mass. So 3.66, 3.45, and 3.44. So this is diet 2 and this is diet 3. And then your total energy intake is 3866 in diet 1, 4088 in diet 2, and 3783 in diet 3. So now we have to kind of see, are these related at all? So we can see that our fat mass in kilograms stays relatively constant. It fluctuates a little bit, but on average, it's fairly, in the big picture, it's fairly constant. And we see a similar thing here with the total energy intake as well. So the total energy intake is fairly constant as well. So you can't really disprove this. It could be related to an increase in total energy intake. We're not really sure because the differences between fat mass and total energy intake are not that great. So it's hard to tell, right? So we'll put a question mark here. Let's go to option B. So increase in lean mass is related to an increase in total energy intake. So looking at lean mass, so I'll say LM, we have negative 0.70 for diet 1. Then we have 2.87 for diet 2. And we have 3.18 for diet 3. So as you can see, from diet 1 to diet 3, there is an increase in lean mass. However, when you look at your total energy intake, that trend is not reflected from diet 1 to diet 3. It's fairly constant, right? And even if it wasn't constant and you were counting these little changes, it's definitely not increasing linearly. And so this we can say is not very well supported by the table. So this is quite a good contender, but let's keep going. So the change in resting energy expenditure is related to an increase in protein intake. So your resting energy expenditure, REE, goes negative 86 to 669 to 949. So that's increasing, as we can see here. And we have to look at the protein intake. And the way that we can find our protein intake, we realize that it's not in table 2. You have to look at table 1. So the protein intake goes from 6% to 15% to 26%. And so you can see that's increasing. So the trends for resting energy expenditure and protein intake are both going in the same direction. So this is fairly supported by the data, right? So this is probably not the right answer. Then looking at the final option, a change in non-resting energy expenditure is not proportional to an increase in total energy intake. So the resting energy expenditure, REE, so this is, non-resting energy expenditure, is 245, 1296, and 756 here. All right. So this is a big jump from diet 1 to diet 2, and then it goes down again in diet 3. And your total energy intake here is, again, fairly constant. So the assumption that it's not proportional is also a valid assumption to make. We can't see any trends that are matching up there, and that's kind of what this one is telling us. So that's a pretty reasonable assumption to make. And so B is the one that's least supported in this case, and so that's our correct answer. So you didn't need any previous knowledge for this one. All you needed to know how to do was interpret different tables and be able to extract the important information from those tables in order to answer the question. And so the bootcamp resources that can help with this is the reasoning skills course, and then also there's an acceleration class on tables that you can watch as well. So question 33 is asking us about the differences in the changes in lean body mass. And so it's saying those changes in lean body mass over the 3 diets is most likely related to what? Is it the percentage of energy from fat, the percentage of energy from protein, or carbohydrates, or just the average energy intake? And when we know from the text that the average energy intake over all 3 of these diets is 140% of the total energy needed to keep a stable body mass. Okay, so that's constant over the 3 diets. So now let's compare. We have lean body mass here. The changes in lean body mass are that they're increasing over the 3 diets, right? So we want to look for something that has a similar trend that can explain this. So looking at fat, the percentage of energy from fat is decreasing. Okay, so the difference in changes for lean body mass is probably not related to fat because the trends are going in opposite directions. Okay, and because this is increasing, it wouldn't make sense if this decreasing value was explaining the increase in lean body mass. Now we have to look at protein. So protein is also increasing, and that follows a similar trend to the changes in lean body mass. So this is a great contender so far. Then we have carbohydrate, which is relatively stable. So that doesn't, necessarily represent lean body mass as well. So we can eliminate this. And then average energy intake, as we know, is also constant. So we can eliminate this. And so the answer is B. With this question, all you needed to do was look at patterns and find the pattern that the question was referring to in order to answer the question. You obviously also needed to know how to interpret tables, and so you didn't really need any previous knowledge here. So the bootcamp resources are the reasoning skills course, the acceleration class on tables, as well as the acceleration class on pattern recognition. In question 34, we're given a statement. So calories alone account for the increase in fat mass, and we're asked to find the strongest evidence for this statement. So looking at this part of the statement, calories alone, we're basically asked to look at the total energy intake, because it's basically saying that you're not looking at the proportion of carbohydrates, fat, or protein, etc. You're just looking at the intake of calories, right? So you would look at 3866, which is the total energy intake for diet 1, 4088, which is the total intake for diet 2, and 3783 for diet 3. Okay, so now let's look at our answer options. It says the increase in fat mass across the 3 diets is supposed to be evidence for this statement. So what we want to do is look at fat mass, and we want to look at the trend for fat mass across the 3 diets and the trend for total energy intake, because that's our calories. And we want to see which trends match up, because we're looking for what these calories account for, right? So looking at the trend for fat mass, we have 3.66, 3.45, and 3.44. And that's a relatively stable unchanging value. Similar to our total energy intake, they're quite similar across the 3 diets relatively. So this is a good contender. This could be evidence for the statement. Now we'll look at option B, the increase in lean body mass across the 3 diets. And so the increase in lean body mass is negative 0.7, 2.87, and 3.18. So that's increasing. And that doesn't really match up with our total energy intake trend. So it's not the best explanation for the statement, so we can eliminate this option. Now, C is asking us to look at the increase in total body mass resulting from diet 2 specifically. The thing is, we can't actually make any conclusions around calories accounting for the increase in fat mass just by looking at one diet. You need to compare different diets to be able to see whether or not calories alone or anything else accounts for the increase in fat mass. And that's the same thing here. We're only looking at one particular diet, and so you can't actually draw any conclusions from that. So these are not good pieces of evidence for this statement. So then the correct answer here is A. For this question, you didn't need any prerequisite knowledge. Again, it was just all about looking at interpreting tables and being able to reason your way through and use your process of elimination in order to come to the correct answer. Question 35 is asking us to draw the best conclusion from a comparison of changes in energy expenditure for each diet. So let's look at our answer options first to look at what the best conclusion is. So answer option A is talking about total energy expenditure. And it says that total energy expenditure depends only on total energy intake. Now, the word only is quite tricky because you often can't draw such a strong conclusion just from this kind of experimental data that we're given here in these tables. Although the trends might match up, you can't confidently say that this is the only thing that's influencing total energy expenditure. But let's look at the trend anyways. So diets 1, 2, and 3, we have our total energy expenditure. We have 159 total expenditure, 159, 1965, and then 1705 as well. And then we have our total intake, which is 3,866, 4,088, and 3,783 here. So over here we have a bit of a trend going up and then it plateaus. And in our total energy intake, it's quite flat. Our trend is quite flat. So you can't really confidently say that total energy expenditure depends on total energy intake only, because first of all, the trends are not matching up, and second of all, this word only is quite dangerous. So we're going to eliminate option A. Then we're asked to look at resting energy expenditure. So resting expenditure depends only, again, that word, on total energy intake. So let's look at resting expenditure. Resting expenditure, we have negative 86, we have 669, and we have 949 here. So this is an increasing trend, and that doesn't match up with the total intake trend. So we can quite confidently, especially because of this word only, say that this is not the best conclusion that can be made here. Then we look at option C. So deviation from normal in the intake of protein limits physical activity. So with the dot points underneath our table 2, we're given some information that we can use here. So physical activity is referring to the non-resting energy expenditure, right? Because we're told that resting energy expenditure is anything other than physical activity. And then resting energy expenditure plus non-resting equals the total energy expenditure. So the only thing other than resting is physical activity, which would therefore refer to the non-resting energy expenditure. So I'm going to do NREXP, non-resting energy expenditure, and we have a trend going on here, 245, 1296, and then 756. All right, so we have a trend going up and a trend going down. And now let's look at our protein. So our protein intake is 6% in diet 1, 15% in diet 2, and 26% in diet 3. And we're also told in one of the dot points that diet number 2 is what's considered normal. All right, so that's a key piece of information, because if 15% is normal and we have the most physical activity here, And when you deviate from normal, you get less physical activity. This conclusion supports that data, right? It's saying that a deviation from normal limits physical activity, which makes us think that when you have something that's other than 15% protein in your diet, that's going to decrease your non-resting expenditure. And this is supported by the table, so we can quite confidently say C. Now, if we look at the deviation from normal in the intake of carbohydrates, the carbohydrates, let's put that in. We have 42%, 41%, and 41%. Now, this is quite a stagnant trend compared to our energy expenditure, which kind of peaks in the normal and goes down in the non-normal diets, right? So these trends don't actually match up. The deviation from normal, we can't really make any conclusions because all three of the diets are relatively normal, and so you can't really draw a conclusion about the effects of carbohydrate intake on physical activity. So we can eliminate this option and be quite confident that our answer is C. So for this question, like the other questions we've been covering, it's all about noticing the trends, right? You don't actually need to really absorb any of the information that they're giving to you, because you don't need to form a full understanding of this information, and that would be a waste of time, and also it would probably confuse you a little bit more, right? You just want to work with what you're given, and in this case, they're asking us to compare trends, and all you need to do is simplify things. So see how I was drawing up the trends like this, and like this? That's a visual way of simplifying the data to make it easier for me to draw conclusions about things. So that's something that you can do for multiple questions on the GAMSAT, and that it comes kind of into the idea of interpreting tables and interpreting any kind of data. Being able to simplify is really important. And so the bootcamp resources that help with this kind of reasoning skills are the reasoning skills course and the acceleration class on tables as well. Question 36 is asking us something a little bit different than the other questions. It's asking us which diet had the most increase in energy intake per kilogram of starting body mass. So diet 1, 2, and 3, the starting body masses were 69.1 kilograms. Then we had 77.6 kilograms. And we had 76.0 kilograms. And now we're looking at the intake, the energy intake. So we're going to just look at the total energy intake. And here we have 3866, 4088, and 3783. So what we want to do is we want to figure out the most increase in energy intake per kilogram of starting body mass. The way that we're going to do this is by basically dividing these numbers, okay? So we would have to do 3866 divided by 69.1. Then we have 4088 divided by 77.6, and then you have your 3783 divided by 76.0. So I've just cleaned up the screen because it's about to get a bit math heavy. So here we have our three fractions that we need to simplify in order to figure out which one has the greatest value, okay? So looking at our numerators, they are quite different. They're different by around 100, right? And what we can do is we can simplify them by approximately the same amount. So we can go 3800, then we can do 4000, and we can do 3700. All right. So in doing that, we've simplified our values a little bit. And now looking at our numerators, we also want to simplify them by a similar amount. So 69.1, I'm going to simplify to 70. 77.6, I can simplify it to around 75. And then 76, I'll also simplify to about 75. So out of these two options here, because our numerators are the same, it makes it a little bit easier to compare. So the numerators are the same, which means that the one with the lower denominator, the denominators are the same, and the one with the lower numerator is going to be the lower value. So here, this is the lower numerator, and so 3 is going to be, so 3 is going to be less than 2. So the energy intake per kilogram of starting mass for diet 3 is less than that of diet 2. So we know that this is not the most, so we can eliminate diet 3, right? Now we can compare these two. So what I will do here is simplify it, so 3800, and this way I don't have to simplify all of them. I've already compared these two, so I don't need to simplify this fraction anymore. So I'm just reducing the amount of maths that I need to do. So I'm going to do this, then here I'm going to, actually I'll keep this here, so because this is 75. What I can do here is divide by 5. So that's going to give me 23 over, dividing this by 5, I'm going to get 800, okay? And then here I'm just going to go 380 divided by 7. And just going to do the basic maths here. So I'm going to do 5. So 35. 3. And that's around 4 approximately. So we have 54 here. And then what I will do here is I'm just going to round this to about 20. And this is 40 is the answer that I get. Okay, so here we have 54 versus 40. And so 54 is definitely greater than 40. So we can say that diet 1 has the greatest energy intake per kilogram of starting body mass. So this is how I would go about the calculations in a GAMSAT setting, especially keeping in mind that you don't have a calculator and you want to save as much time as possible. It would not be very time efficient for you to go and try to figure out the exact values for each of these fractions. That would simply take way too much time. So simplifying it in this way is going to be very important. So like I said with this one, you don't need any previous knowledge. All you need is the calculations aspect of it and being able to work around these sort of calculations quickly by simplifying and rounding. And the bootcamp resources that can help with this are the reasoning skills course and the acceleration class on calculations and formulae. And that brings us to the end of this unit. So please like, share, and subscribe for more GAMSAT help. We love your feedback. We have our Instagram here at Thank Flip GAMSAT and our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT, if you want to hear more from us. All right, I'll see you in the next one.